10.1 circle equations in standard form. So a definition here, a circle is the locus or set of points in a plane equidistant from a given point. So that would be if you have a radius or a center here, if you have the center, we name it as HK. And then from the center to any point along the circle would be the length of the radius. And then if you would put a line through the center straight across, that would be the diameter. And this is a standard form. So we name our center on the inside of our parentheses. So this would be the x coordinate of our center, h. K is our y coordinate of our center, and then it's equal to our radius squared. So example 1, write an equation for a circle with a center -1, 3, and a radius 6. So if we use our same equation from above, x minus -1 squared plus y minus 3 squared is equal to 6 squared. Now we have to simplify this, so that becomes x plus 1 squared plus y minus 3 squared, and then 6 squared is 36. Now I can usually do this just in my head. Just know that whatever's on the inside of the parentheses is the opposite sign of your center. So if your center is -1, you're going to be adding 1 on the inside of your parentheses. If your center is +3, you're going to be subtracting 3. And then your radius, you have to square that number to set it equal in standard form. So example 2, write an equation for a circle with a center at 0, 0. So if your center is at 0, 0, then you're not going to be adding or subtracting anything from your x or your y. Now you can technically put that in as x minus 0 squared plus y minus 0 squared, and then your radius, you have to square that. But since you're not adding or subtracting anything, that number is just 0. You can just write it as x squared plus y squared. So if you see this, that means that your center would be the origin, or 0, 0. And then 3 square root of 7 squared, remember that this is 3 square root of 7 times 3 square root of 7. 3 times 3 is 9. Square root of 7 times square root of 7 is just 7. So 9 times 7 is actually 63. And you could put that right in your calculator and say 3 square root of 7 squared. That would come out to be the answer of 63, as long as you put that into your calculator correct. So if you put that in, you would need the parentheses right around the on the outside of your square root, like that. Example 3, write an equation for a circle with a center at 0, 3 and passes to the point 2, 7. So if I have a center here at 0, 3, I'm going to go up 3 units, and it passes to the point 2, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. I need to find my radius, and my radius is going to be the distance between these 2 points. So before we do anything, you have to find the distance between those 2 points. We are going to be using our distance formula. And again, this is to find the radius. The distance between our center and that point would be our radius. So here, going to subtract our x's, so 0 minus 2 squared, and then subtract our y's, 3 minus 7 squared. Remember that the order here doesn't matter. You can switch them up. It doesn't matter. So here, square root 0 minus 2 is just -2 squared, plus 3 minus 7 is -4 squared. -2 squared is 4, plus -4 squared is 16, so this is the square root of 20. So that means that our radius is the square root of 20. Now, when we go to put that into our equation, again, we're not adding or subtracting from our x's, so I'm just going to put x squared, and then we are It's a positive 3. Remember, it's the opposite sign on the inside of our parentheses. And then we have to take our radius and square it. Now, square root and square are opposite operations, so this actually becomes x squared plus y minus 3 squared is equal to 20. Example 4, determine the center and a radius of a circle with the equation x plus 3 squared plus y minus 6 squared is equal to 90. So again, this is going to be your x coordinate of your center, and this is your y coordinate of your center, but it's the opposite sign. So our center is going to be negative 3, positive 6. And then our radius, you're taking whatever it's equal to and taking the square root. So it's 90, the square root of 90, which can be, just to simplify this, because we have talked about simplifying radicals before, you're looking for the highest perfect square that goes into that, which I can see automatically is 9. Square root of 9 is 3, so it's going to be 3 square root of 10. So my center here is negative 3, 6, with my radius of 3 square root of 10. Example 5, a circle has endpoints of a diameter of 4, 2. So I'm going to graph that. 2, 3, 4. Here's 1. And negative 2, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now they're telling us this is a diameter. So remember, diameter goes all the way across, straight through the center of the circle, and a radius starts at the center and goes to one side of our circle. So in order to find the center is the same thing as the midpoint of this segment, because I need to find equal distance between these 2 points to find that point exactly in the center. And to find the midpoint, we're taking our x's, dividing by 2, taking our y's, dividing by 2. Remember, it's just to find the average between those 2 points. So here, our x's are 4 plus negative 2 divided by 2, and our y's are 2 plus 10 divided by 2. 4 plus negative 2 ends up being 2. 2 plus 10 is 12. 2 divided by 2 is 1. 12 divided by 2 is 6. So our center here is 1, 6. Now, to find the radius, you have to take the center and so you have a few different ways that you could do this. You could take the center and one of those points to find the distance between them. Or, because we solved for the center, I recommend taking these 2 points and finding the length between them, and that would be the diameter. So let's go ahead and do that. So again, the distance formula, x minus x squared plus y minus y squared. So again, I'm just going to take these 2 points, and the length that I solve would be the diameter. So 4 minus negative 2 squared, and then those are my x's, and then my y's, 2 minus 10 squared. 4 minus negative 2 is 6, so that's 6 squared. 2 minus 10 is negative 8 squared. 6 squared is 36. 8 squared is 64. Remember, when you're squaring a negative, to put that into parentheses. You know that a negative squared will always be a positive. And then 36 plus 64 is 100. And the square root of 100 is 10. And now I told you that is our diameter. So to find the radius, cut it in half. So 5 would be our radius. So diameter, once again, diameter goes straight through the center all the way across the circle, and our radius starts at the center and goes halfway across. So that's why our radius here would be 5. And then to find the equation of our circle, plug in our points. So x minus 1 squared plus y minus 6 squared, and then we're setting it equal to our radius squared. So 5 squared, which is x minus 1 squared plus y minus 6 squared, and then 5 squared is 25. Make sure you always simplify that radius if you can. So here 5 squared, 25. So don't leave it as 5 squared. Make sure you write 25 down for your final point. Example 6, what is the radius of a circle with a center 3, negative 2 that contains 5, 2? So again, a center, if I have a center at 3, negative 2, here's my center, and it contains 5, 2. So 1, 2, 3, 4, 5, 1, 2. So if it contains it, that is 1 point on our circle. So the length between them would be our radius. So again, use the distance formula. So I'm just going to use these 2 points, find the distance between them. So 3 minus 5 squared plus negative 2 minus 2 squared. 3 minus 5 is negative 2. Negative 2 minus 2 is negative 4. Negative 2 squared, again, negative squared is always a positive, so that's going to be positive 4. Negative 4 squared is a positive 16. So that's the square root of 20. So our radius is the square root of 20. And that would be your final answer. All right, so number 7, graph this equation. So first figure out what your center is. So remember, your center is always the opposite sign in here. So you're taking the opposite sign. So my center is going to be positive 2, positive 1. And my radius, you're taking whatever it is equal to and taking the square root. So square root of 9, which is 3. Now, to graph this, I would start by graphing your center. So our center is 2, 1. And then for our radius is 3. So take your center, always count horizontally or vertically, because then you know you're actually counting 3 units. So 1, 2, 3, here's a point. Start at your center and count 1, 2, 3. There's a point. Again, start at the center, 1, 2, 3. Start at the center, 1, 2, 3. And then connect all of those points. That wasn't the best, but you understand the idea there. So start at your center, count right, left, up and down the amount of your radius. So here we counted 3 because our radius was 3 units. And then draw a circle between those 4 points. Example 8, write the equation of a circle. So again, identify our center. Our center is 1, negative 3. Then to find our radius, you are just going to start at the center. Always count right, left, up or down, horizontally or vertically. Do not count skipping units. So I'm not going to count diagonally. I'm always going to count horizontally or vertically. So start at the center and count to one side of your equation or your circle. So 1, 2, 3, 4, 5, 6, 7. So our radius is 7. So I started at my center and I actually counted to the right. So I started here and I counted to right there. Again, you can count straight up, over to the left, or straight down, as long as you're counting vertically or horizontally on a straight line. And then to plug that into our equation, x minus 1 squared plus y, again, opposite sign, so since that's a negative, I'm going to be adding 3, and then equals 7 squared. So it becomes x minus 1 squared plus y plus 3 squared is equal to 49. And that would be your final answer.